Types of liquid solutions. There are two types of liquid solutions. One is ideal solution and another one is non-ideal solution. Ideal solution means the solution which obeys Raoult's law is called ideal solution. The solution which does not obey Raoult's law is called non-ideal solution. Obey Raoult's law means in that solution the relative lowering of vapor pressure is equal to its mole fraction of solute. Such solution is called ideal solution. If relative lowering of vapor pressure is not equal to mole fraction of solute, that solution is called non-ideal solution. So that is the explanation for ideal and non-ideal solution. So ideal solution means the solution which obeys Raoult's law is called ideal solution. So for example, if I take two liquids, let us assume they are A and B. For example, water, HNO3. Suppose for example, in water there are so many water molecules are there. Between those molecules attraction forces are present. Similarly in HNO3, this is also liquid. In that HNO3 there are so many HNO3 molecules are there. Between HNO3 molecules some attraction forces are exist. Here the point is the attractions present in water molecules is equal to the attractions present in HNO3 molecules. That means the attraction forces in water is equal to attraction forces in HNO3. If water, suppose for example water mixed with HNO3, then also attraction forces exist between water and HNO3. Here the point is the attractions between water molecules and HNO3 molecules and water and HNO3 molecules are same. Such solutions are called ideal solutions. I repeat once again. I take two liquids. One is A and another one is B. In A liquid there are so many A molecules are there. In B liquid there are so many B molecules are there. Between A molecules attraction forces are exist. Between B molecules attraction forces are exist. Here the point is the attraction forces in A molecules is equal to attraction forces present in B molecule. When A reacts with B or when A mixed with B, then also attraction forces present between A and B. Here the point is those attractions are also equal to individual molecules of A and individual molecules of B. That means the attraction forces in AA molecules is equal to attraction forces in BB molecules, that is equal to attraction forces present in AB molecules. Such solutions are called ideal solution. So the explanation is here: attractions between solute, solvent and solute are similar. Such solutions are called ideal solution. In forming such solutions, delta H mixing equal to 0. That means when we mix A and B liquids, there is no chance of releasing heat and there is no chance of absorbing heat. So delta H mixing is equal to 0. And similarly delta V mixing is also 0. That means, for example, the volume of A is 5 ml and the volume of B is 5 ml. For example, suppose the volume of A is 5 ml and the volume of B is also 5 ml. When we mix with A and B, then we get 10 ml. That means there is no change in resultant volume. That is why delta V mixing is equal to 0. So these are the properties of ideal solution. These are very important points. during formation of ideal solution, delta H mixing equal to 0 and delta V mixing is also equal to 0. For example, when we mix benzene and toluene, the attractions between benzene molecules and toluene molecules and attractions between benzene and toluene molecules are same. So these are the example here, and one more example is there, that is N-hexane and N-heptane. Here also the attraction forces between hexane molecules and heptane molecules, and hexane and N-heptane molecules are same. So here you should remember these examples. Here these examples may ask for one more question. Here the graph is there. This is the graph regarding ideal solution. Before going to explain this graph, I will explain one point. That is, according to Raoult's law, one statement is there. Between vapor pressure and mole fraction, directionally proportional is there. That means as mole fraction increases, vapor pressure also increases. Here I draw the graph between vapor pressure and mole fraction. So between vapor pressure and mole fraction, directionally proportional is there. That means as mole fraction increases, vapor pressure also increases. So the graph appears like this. This graph represents Raoult's law statement. Here I explain one more graph, that is, here also graph drawn between vapor pressure and mole fraction. Here I take two liquids. One is this side and one more is this side. Here XA, suppose for example XA equal to 0, here XA equal to 1. Here XB equal to 1, then here XB equal to 0. I take two liquids. This is one liquid and this is another liquid. The sum of mole fraction of solute and solvent is 1. Here 0 plus 1 becomes 1. Here 1 plus 0 becomes 1. So I take two liquids. If the point is, from here to here, mole fraction of A increases. From right to left, mole fraction of B increases. So here also vapor pressure increases along with XA. That means here we can draw the graph like this. So this line indicates that vapor pressure with respect to A. Here I take one more line, that is, from right to left, XB, that means mole fraction of B increases from right to left. Here 0, here 1. That means from right to left, mole fraction increases along with vapor pressure. So we can draw the graph like this. This line indicates that vapor pressure of B. This line indicates vapor pressure of A. Now, if you join these two lines, this is called vapor pressure of A. Vapor pressure of B. This line is vapor pressure of A. So the sum of vapor pressure of A and B is equal to total vapor pressure. So this graph indicates that ideal solution. This graph belongs to ideal solution. I repeat once again. According to Raoult's law, between vapor pressure and mole fraction, directly proportional relation is there. That means mole fraction increases, vapor pressure also increases. So the graph appears like this. This is for one liquid. Now I take two liquids. One left side, one is right side. Here you are assuming that XA equal to 0, XB equal to 1. Here XA equal to 1, XB equal to 0. This is first liquid, this is second liquid. Here the point is, from left to right, mole fraction of A increases. From right to left, mole fraction of B increases. So from left to right, mole fraction of A increases. That means if mole fraction increases, vapor pressure also increases. So this line indicates vapor pressure of A, nothing but PA. This line from right to left, mole fraction of B increases. So that this line vapor pressure, So from right to left, if mole fraction increases, vapor pressure also increases. So this line indicates that vapor pressure of B. When we join these two lines, that means PA plus PB equal to P total. So this graph belongs to ideal solution. So this is the actual graph. So here the point is, in ideal solutions, the attraction between solute, solvent, and solute and solvent are same. In forming such solutions, delta H mixing equal to 0. Delta H mixing equal to 0 means if we mix those two solutions, there is no chance of evolving heat, there is no chance of absorbing heat. Delta V mixing equal to 0 means if we mix with those two liquids, then there is no change in volume of resultant mixture. That is why delta V mixing equal to 0. So this is all about ideal solution. Next, non-ideal solution. Non-ideal solution means the solution which does not obey Rolle's law is called non-ideal solution. Here two cases are there. One is positive deviation and another one is negative deviation. These two are very important. Positive deviation means attractions between solute solvent is less than solute and solvent. For example, if I take A and B, two liquids, between in liquid A there are so many A molecules are there, in liquid B there are so many B molecules are there. Between A molecules some attraction forces are exist, between B molecules also some attraction forces are exist. Here the point is, when these two liquids mix with each other, the attractions between AB is less than attractions between AA and BB. When these two liquids mix with each other, the attractions between AB, that means solute and solvent, is less than solute and solvent. So the point is, attractions between solute solvent is less than solute and solvent. In forming such solutions, delta H mixing is greater than 0 and delta V mixing is also greater than 0. These are very important points. These are properties of non-ideal solutions in positive deviation. Delta H mixing greater than 0 means when those two liquids mix with each other, then heat is absorbed. That means it is endothermic reaction. Delta V mixing greater than 0 means, that means, for example, the volume of A is 5 ml, the volume of B is 5 ml. Suppose the volume of A is 5 ml, the volume of B is 5 ml. When these two volumes, that means when these two liquids mix with each other, we should get the total volume of 10 ml. But here we will get more than 10 ml volume, because here the attractions between solute and solvent are very less. If attractions are less, the molecules moves apart from each other. If molecules moves apart from each other, then its total volume increases than expected. That is why delta V mixing is greater than 0. I repeat the point once again. Delta H mixing greater than 0 means when those two liquids mix with each other, then heat is absorbed, that is endothermic reaction. Delta V mixing greater than 0 means, that means, suppose for example the volume of each liquid is 5 ml. When these two liquids mix with each other, we should get 10 ml. But in this case, we should get the volume more than 10 ml, because the attractions between solute and solvent is very less in this case. If attractions are very less, the molecules apart from each other. The molecules move apart from each other. When the molecules move apart from each other, the total volume is more than expected. So these are properties of positive deviation of non-ideal solution. Example, acetone ethanol and acetone carbon disulfide. Here you should remember these properties and examples. These are very important point. Here one more important point is there, that is, in this case total vapor pressure is more than required or more than expected, because here the attractions between solute and solvent are less compared to solute and solvent. If attractions are less, automatically those liquids are readily undergo evaporation. If they readily undergo evaporation, they exhibit more vapor pressure than expected. So that is why the graph represent like this. Actually this dark lines indicates ideal solution. Here these are dotted lines. This dotted line indicates that here this line indicates vapor pressure of A. Here this line indicates vapor pressure of B. Here these dotted lines indicates that here this line indicates that here the vapor pressure is more than expected. This is the line regarding A liquid. Here small mistake is there in case of B liquid. Here we should draw the graph like this. So here these dark lines indicates ideal solution. This is expected vapor pressure. But here what happens? The attractions between solute and solvent are very less. So automatically what happens? If attractions are very less, they exhibit more vapor pressure than expected. So A liquid exhibit more vapor pressure than expected. This is expected. B liquid also exhibit more vapor pressure than expected. So this line indicates total vapor pressure. This is expected total vapor pressure. Here also total vapor pressure exhibited more than expected. So this graph indicates that positive deviation of non-ideal solution. And one more thing, that is negative deviation. This is exactly opposite of positive deviation. Negative deviation means here attractions between solute solvent is more than solute and solvent. That means if I take two liquids A and B, the attractions between A molecules and B molecules are similar, but when these two liquids are mixed with each other, the attraction between A and B is more than individual A molecules and individual B molecules. If attractions are more between A and B, then those molecules readily do not undergo evaporation. If they do not undergo evaporation, they exhibit less vapor pressure than expected. I repeat once again, when these two liquids mix with each other, here the attractions between solute and solvent is more. If the attractions are more, they do not undergo evaporation easily. If they don't undergo evaporation easily, they do not exhibit more vapor pressure. They exhibit less vapor pressure than expected. So that is why this is called negative deviation. In forming such solutions, delta H mixing less than 0. Less than 0 means negative value. That means when these two liquids mix with each other, exothermic reaction takes place. And delta V mixing is also less than 0, because when these two liquids mix with each other, the resultant volume is less than expected. For example, take 5 ml of each liquids. When these two liquids mix with each other, the total volume should be 10 ml. But in this case, it is less than 10 ml. In previous case, it is more than 10 ml. In this case here, it is less than 10 ml. Because here, when these two liquids mix with each other, the attractions between solute and solvent is more. If the attractions are more, the particles comes close to each other. If the particles comes close to each other, the volume of the liquid reduces than expected. That is why delta V mixing is less than 0. Here example is H2O plus HNO3, H2O and HCl. These examples and these properties are very important. Here you should remember these points. Here one more point is there. In this case, total vapor pressure is less than required, because the attractions between solute and solvent is more. If the attractions are more, they do not undergo evaporation easily. If they do not undergo evaporation easily, they exhibit less vapor pressure. Here graphically we represent like this. This dark line indicates expected pressures, but here this pressure indicates vapor pressure of A. This line indicates vapor pressure of B. This is the line regarding vapor pressure of A. This is the line regarding vapor pressure of B. So this is the dotted line regarding vapor pressure of A. This is the dotted line regarding vapor pressure of B. That means they exhibit vapor pressure less vapor pressure than required. This line indicates total vapor pressure. Actually this is expected total vapor pressure. Here the attractions between solute and solvent is more, so that they exhibit less vapor pressure. So this line indicates less vapor pressure. If the dotted line is present above the dark line, that is positive deviation. If the dotted line present below the dark line, that is negative deviation. Here you no need to remember these graphs. Here you should remember properties, that means delta H mixing, delta B mixing, and examples. These are very important. This is all about types of liquid solutions, nothing but ideal solution and non-ideal solutions.